Every time driver reverse a car, there's only one thing that determines whether the journey ends safely. Measurement. Not distance, not speed, not luck. Measurement. But have you ever wondered if measurement is so essential in our everyday life? Why do so many students still struggle about it to truly understanding about measurement? Perhaps the challenge has never been the measurement itself. Perhaps it's the way we teach it. Measurement is one of the earliest mathematical concepts that introduced to every child, from measuring a pencil to calculating the dimensions of a classroom. Measurement helps us make sense of the world around us. It's not about simplifying numbers, but it's about understanding space, accuracy, distance, and also relationship between two objects. And also, these are fundamental skills that students will continue to use throughout their life. However, despite its importance, the way a measurement is taught in classroom has changed very little over the years. In many classrooms, students are still introduced about measurement through textbooks, worksheets, and also measurement tools like they learn about the formulas, they memorize the unit, they do the exercise, and lastly, they prepare for examinations. But learning to measure is very different from understanding measurement. So, traditional measuring tools are certainly remain valuable. They are simple, reliable, and essential in every mathematics classroom. However, they provide only a single measurement. They do not offer immediate feedback. They do not encourage students to analyze changing distance in real time, and they rarely transform measurement into an active learning experience. As future mathematics educators, we believe that students deserve more than simply reading measurements. They deserve the opportunity to explore them, to compare them, to question them, and learn from them. Because meaningful learning happens when they understand through experience, not merely by memorizing answers. That single belief became the starting point of our innovation.
So, what exactly is Arduino? Arduino is actually an open source microcontroller platform designed to make electronics and programming simple, accessible, and also affordable. Since its introduction in 2005, it has become one of the world's most widely used educational technologies, empowering millions of learners to transform ideas into real working solutions. Its affordability, ease of programming, cross-platform compatibility, and a strong global community have made it a powerful tool in education, particularly in science, technology, engineering, and mathematics, better known as STEM. So these characteristics are also highlighted in the MMA version 3 module as a key reason Arduino is well suited for educational innovation. At the heart of our innovation is the Arduino Uno. Think of it as the brain of the entire system, just as the human brain receives information, processes it, and decides how to respond. The Arduino continuously receives information from its sensors, processes the data within milliseconds, and produces meaningful outputs. To measure distance, our innovation uses an ultrasonic sensor. Rather than relying on a physical contact like a ruler or measuring tape, this sensor measures distance using sound waves. It sends out high-frequency ultrasonic waves that are inaudible to the human ear. When those sound waves strike an object, they bounce back to the sensor. By calculating the time taken for the waves to return, the Arduino instantly determines the exact distance between the sensor and the object. Within fractions of a second, the measurement is displayed in the real time. Now, let's imagine a mathematics lesson. Before taking any measurement, the teacher asks a simple question. How far do you think the temple is from the wall? One student answers, I think it's 1 meter. Another says maybe 80 centimeters. There is no immediate correction. Instead, they investigate. The alternate sensors measures the distance. The Arduino processes the information. The LCD immediately displays 87 centimeters.
So, as we continue observing students during their learning activities, we noticed something remarkable. They were no longer asking, is my answer correct? Instead, they began asking, why is my answer different? And that changed the entire learning experience. Both students measured the same table, yet their readings were slightly different. One got 23 centimeters and the other got 22 centimeters. At first, they assumed someone had made a mistake, but instead of immediately giving them the answer, the teacher asked another question. Why do you think your results are different? Almost instantly, the classroom transformed into a community of young investigators. Some students suggested that they measure from different starting points. Others realized that the angle of the sensors influenced the reading. Some also discovered that moving the device even slightly changed the measured distance. So, without being told, they began exploring one of the most important concepts in mathematics, measurement accuracy. This is the difference between learning about measurement and learning through measurement. Students are no longer passive recipients of information. They become active investigators. They observe, they question, they test, and they justify, and also they reflect. Rather than accepting the first result they obtain, students naturally repeat the investigation. They compare multiple readings, they identify patterns, they recognize variations, and they begin discussing consistency, accuracy, and possible sources of error. These are not simply mathematical procedures, these are scientific habits of mind. At this point, our innovation is no longer functioning as a measuring device alone. It has become a learning environment, one that integrates mathematics, scientific inquiry, digital technology, and collaborative learning into a single classroom experience. Because the true purpose of education is not simply to help students measure distance, it is to help them understand why that distance matters. And why students became increasingly engaged with the measurement, another interesting pattern emerged. They were responding only to the numbers displayed on the screen. They were beginning to respond to the sounds. At this point, you may be asking yourself, why create another measuring device when ruler as already exists, when measuring tapes are inexpensive, widely available, and has been used successfully for this generation? That's a fair question, and it's exactly the question we asked ourselves at the very beginning of this project. Our goal was never replace the traditional measuring tool, in fact remain essential in every mathematical classroom. Students should learn how to use ruler correctly. They should still understand how to read the measurement scale, and they should still experience manual measurement because these are fundamental mathematical skills. Our innovation transforms measurement from a single answer to a complete learning process. Students begin by making a prediction. I think this table is 1 meter long. Then they investigate, they collect evidence, they compare their prediction with the actual measurement. They discuss the differences, they analyze the result, and finally, they justify their conclusion using mathematical evidence. There is no longer a simple measuring activity. It becomes an inquiry, a discussion, a reflection, a meaningful learning experience. Version 3 introduced a 3-level change audio feedback system, not to replace the numerical display, not to replace mathematical thinking, but to enhance students' awareness of changing distance, while keeping their attention focused on the object they are measuring. Because in real-life situations, we rarely rely on vision alone. We constantly process information through multiple senses, and meaningful learning becomes even more powerful when students are able to see, to hear, and experience mathematical concepts simultaneously. The question was never, can Arduino measure distance? Because it already can. The real question was, can Arduino transform the way students understand distance? With MMA version 3, we believe the answer is yes.
Every innovation should answer one important question. Does it truly improve learning? For us, that question has always been more important than how advanced is the technology, because technology alone does not transform education. Learning does. Learning becomes more collaborative. Students work together to compare measurements, justify their findings, and explain their reasoning. So every discussion became an opportunity to communicate mathematical ideas. So every investigation became an opportunity to build confidence.
So that's all from us. Thank you.